Today we will talk mostly about electricity consumption, but just so you know it, we also have other models for other parts of the energy industry. So for like wind and solar and so on. What we also have done is that we have opened up our system so it should be transparent for you. So you can create your own models. So it can be other models than this, but it can also be that you want to modify the models that we have. So it's possible if you want to write code, you can use the infrastructure that we have with having imports of measured data and weather and so on, and then you can write your own models. But otherwise we have a set of models ready-made and that we have run for many years, so they are very well tested and used by many different customers. I think we have 60 energy companies today using our system, so they are used on very many markets and for different aspects. One thing that we have in the system is that we use multiple weather providers. Since weather is such an important part of energy forecasting, we don't just want to use one weather provider, we want to use many. And you can more or less use an infinite number of weather providers. Most commonly we use 5 weather providers, but you can use more than that as well. And for each of these weather providers we create an energy forecast, and then in the system you can find the optimal weight. You can either set the weight manually that you want to use 30% of this and 50 of this one and 20% of that one to weight it together, but you can also let the system optimize this for you, and so the system finds the optimal weight. And you can set these weights for different forecast horizons. So this is the forecast for forecast hour number 1 to 12, and you have one weighting for that, but then you have another weighting for the coming hours and so on. And the case could be that one of these providers are better than the others for long-term forecasting, whilst the others are better for short-term. So then you can have different weightings for different intervals. In the system, besides having a forecasting system, we also have an evaluation system, a follow-up system. Because when we do the forecast, we save all the information, more or less, when we did the forecast, so that we can go back later on to do an evaluation of this. And except for the forecast made in Aiolos, you can also evaluate if you make a forecast in another system. So external forecasts can be imported to Aiolos just as easy as you import measured energy. You can import an external forecast, and you can weight that together with your forecast, and you can also evaluate it in this follow-up. Other things you can do in follow-up is that you can compare how good was the manual made forecast with the automatic, how does it go for different users, and so on. And the aim is that it should be a one-click system once it's set up. And moving on to the installation, that we have a cloud-based solution, so you don't have to install anything at your site if you don't want to. You can run it through Internet Explorer, a web browser window more or less. But then it is possible as well to install it on a local server at your site if you want to. And then we run it in 64-bit, and we support different kinds of resolutions, so hopefully one of these fits your need, but it should also be easy for us to change that. But we have prepared already for resolution between 5 minutes and 60 minutes. That was what I was going to show you in a PowerPoint, but let's go to the system so you get to see a lot of that. So this is how Aiolos looks like when you start it up. And then you have empty windows here, but if I push this play button, we make a forecast. And then you see a progress bar in the bottom to see how things are going, and then you get a status pop-up of this. I can come back to that. And in this case then we have a summed series called customer demo, but that series consists of other sub-series. So consumption is mostly interesting today, but as you see we also import some external made forecasts made from in another system. We have made a solar forecast, solar power, and wind forecasts, and so on. But let's take a look at this consumption forecast. And the consumption forecast itself, it contains of forecasts made in different geographical areas, so area A and area B. And each of these consists of different forecasts. So in this case we've made the same forecast, the forecast for area A, but we made it in two different ways. So we've used the calculation model Aiolos for one of them and the calculation model Celia for the other one. So here you get to see them all in the same diagram like this, so you can compare what does Aiolos think and what does Celia model think in this case. And then you can weight these two together. So in this case we have 60% of the Aiolos forecast and 40% of the other. And this we have set manually, but you can let the system calculate what would be the optimal weight looking at an historic period and set these weights from that. And this could be internal forecast like it's today, but it can also be that you want one of them to be an external made forecast made in another system. So you can still use them like this. So here you see the diagram of your energy forecast. Below that you have the weather forecast. So here we see the temperature forecast, the wind speed forecast, and the global radiation. So we can take a look at that together with the energy forecast. And over on the right hand side we see in the grid we see the individual values written in a spreadsheet form instead. And we have all values that we see here we see in the spreadsheet, so we can scroll through that. And then we have some totals summed up like this. But what we see here, everything is configurable. So let's say that you don't want to see the totals, then you can move them away like that. I pushed the needle button, and if you want to see it, you have it there, and if you want to, you always want to see it, then you can pin it back to this again. You can also adjust all the windows, so if you want this to be larger, you can just make it larger. Or if you have multiple screens, then you can just rip this out of the rest of the container and put this in full screen mode if you want to see that instead. So this should be able to optimize according to how you want to see it. But let's go forward then with the forecasting process, and let's say that you want to make this Aiolos forecast. So one thing that you might want to do when you made this forecast is that you want to compare it with the historic data, and then you can add this data. So in this case we had real-time measured data, so we had data up until now. In many other cases it might be that we don't have data for the last days, weeks, or even months sometimes. So that depends on your setup and what you have. But Aiolos is supposed to manage everything of that. So here we took a look at the last 2 days, and we see that our forecast is quite high compared to this last 2 days. But we can take a look at the last 3 weeks. then we see that, okay, the last 2 days was a weekend. It was a Saturday and Sunday, so all weekends are a bit lower. So our forecast is at least higher than that, but lower than the other weekdays, the last couple of weeks. So this is one way to look at the history, and if you then want to do any changes, you can do this directly here in the diagram. We can take a look at the history in another way, and I can show you. So you can easily toggle this, and let's say that you want to look at the last year, you can just add that to the system as well. But let's take a look at the history in another way. So we still want to look at the last couple of weeks, so the last 3 weeks, but we take a look at them and put the data on top of the forecast instead of in a long string before the forecast. So here we see 2 days of history, 27th of March and 28th of March, 20th and the 21st, and so on. And let's say now that you want to do change your forecast. Then you can just click and drag to mark an area, and then you can adjust that area for all values at the same time. You can also click to mark a smaller section if you only want to adjust this part, and then click and drag. And when you do these changes, you will see that the values are changing over in the grid. So if we try this again, you see the values are changing over there. So they are immediately updated. And you can do the changes like I did here by clicking and dragging, but you can just as well do the changes here. So you can write them in relative terms. So I want 50% of the original forecast for that hour or for many hours. And then we see the change is being made directly in the diagram as well. So you can change it by relative terms, or you can write the amount of megawatts that you want to change. So maybe we want to add 400 megawatts to this one, and that is possible as well. And if you, like I did now, almost lost track of your original forecast, then you can just push Ctrl-Z and say, I want to undo all the changes that I did, and then we go back to 100%. So that is one way to analyze the forecast. Another way to analyze is to look at the different weather providers. I mentioned that we can have different weather providers and do the same forecast, but for different weather providers. So in this case we have weather provider number 1 and the forecast, and in this case the forecast is consisted of 100% of weather provider number 1. And then we have the suggestion from weather provider number 2 and from number 3. So we can also do changes to the forecast because of this, and we can also let the system optimize between these 3. But we can come back to looking at how to change these values, so it's not 100% of weather provider number 1. Other things that you can do, because now when we added different weather providers, we saw that this diagram was filled with a lot of data, so it's almost hard to see and to analyze the differences between these. So what we can do is that we can remove some information if we don't want to see everything. So here I will remove the wind speed and the global radiation, and only take a look at the temperature. And we could also change the color if we think this should not be blue as well. If we want it to be orange or some other, it's just to change this directly here in the diagram. no, this one didn't change, but this can very easily be changed to the color that you want. We saw this here, this example. It's easy to change, and then to save the new colors if you prefer other colors. So we can do that, and then when we've made all our changes to the forecast and we've analyzed it, we can do an export. And normally we export to a file that is being sent away, or to an Excel file, or writing in a database or anything like that. But just to show you an example, we can export this to Excel. Take a look at it, and we can, if we want to choose where we want to save it. So then I get all the values in Excel. So here we can take a look at these different forecasts made if we want to in Excel instead. But let's go back and change this weighting for this Aiolos forecast. So if we right-click here, we see that the weights for Aiolos forecast are 100% of weather provider number 1. But if we want to, we can add several intervals and have different weightings for different intervals. But in this case, we can make it easy for ourselves and say that we do one optimization. So like that. So now it's more evenly spread, and we get a save symbol, so we can save it. So let's make a new forecast then for the Aiolos forecast. So in this case now, before it was weather provider number 1 was exactly the forecast, but now the forecast is more in the middle of all of these, as you see. So this is possible to do. Then I mentioned the follow-up as well, that we can do a follow-up inside the system. So in this case we have different settings here, so I will take a look at the day ahead forecast. But this can also be the intraday forecast, 1 hour ahead or 1 week ahead or anything alike. And then we will take a look at 2 weeks time during this period. So now we see the day ahead forecast versus the measured data. And in this case it's quite a disaster, I would say. The forecast is quite bad, but that is the intention as well. Because if you're here on the summed level, you want, if it looks like this, that your forecast is way off the measured data, then you want to be able to zoom in and zoom down. So then you can take a look at the consumption, and this is, well, it's at least all right. It's not a disaster at least. And in this case, we haven't imported the external forecasts for all hours. We have it intraday, but not day ahead. We have the solar that we can take a look at, and so on. But let's take a look at this consumption then. So if we take a look here, then we can, if we want to analyze something further, we can also mark an area and zoom in. So then we see the day ahead forecast and the measured data during that period. And we see here that we are zoomed in. And here we can scroll through different periods if we want to take a look at something else. And then we can make the analysis of the evaluation of the forecast. So here you can, besides evaluating this energy forecast, you can also take a look at what was the weather provider's forecast day ahead. So you can compare the day ahead temperature forecast with the observed temperature. So from that you can also make analysis of what might have happened if the forecast has been off, and so on. And the same goes here, that everything that you see here you have in a grid over here. And you also get to see the statistics for this period. So here you can look at different measures, like what was the mean error for this period, what was the mean absolute error, and what was the mean absolute error in percentage, and so on. You have different statistic measures that you can do this follow-up from. So that was the quick follow-up. We can also take a look at this individual weather. So let's do this for this consumption area A, the Aiolos forecast. So here we get to see the energy forecast from each of these different weather providers. So we get to see weather provider number 1, weather provider number 2, number 3, and so on. So we can compare them directly here in the diagram, but we can also compare them here in this statistics and see that in this case weather provider number 2 was the best one. The weather provider number 1 had this error, and so on. So we can make a very quick evaluation of that as well. Then to work with the system, it's very easy to add a new series. So if we go over to not your daily work maybe, but if you, let's say that you want to add a new series, then you can do that. So my series. And here I selected what kind of historic data do I want for this series. Normally you want to set up a new series and then import data to this series, but now I selected a file that has historical data from before. And then you want to select which calculation model do you want. Is it a Celia model that we call it in Aiolos, or have you written your own model, and so on. Do you want to export the forecast somewhere? Do you want to import data? In this case, no. And what weather do you want? And this normally is what is the city, like for me it could be Stockholm, and from which weather provider. Is it SMHI or YR, or which one is it? But let's select one of these here. So site 1 from weather provider 3, and then save. And when I save this, we see that it pops up here in the window. So my series we have there now. And if we go back to home where we make the forecast, we see that we now have this my series. And if we select that series and push play, then we can see if we can make a forecast of it. Yes, so as easy as that, we made the forecast. We see now that weather provider 2 and 3 and so on are 0, since we didn't set any weather provider on place number 2 and 3. But so here we have the forecast. What we haven't talked so much about is that every time I made a forecast, you've seen that it pops up a screen or a pop-up message. We can make the forecast for all of this again, like this. And this can help you keep track of your data status. So in this example here, we have measured observed weather, which you need for your energy forecast, and weather forecast. And in this case, we see warning symbols for some of them. So this is an example of that. If you would be missing weather observations, then you can get a warning like this, so you're alerted that something is missing in the system. And this could also be for weather forecast or for measured energy. So if something goes missing, you can get this as a warning in the system, but you can also get this sent out to you in an email or anything else like this if you expect the weather for this time, but you haven't gotten it. So that was a very brief introduction of this system. We can just sum it up and say that when you start the system, you have your series marked, or you mark the series that you want to make a forecast of. Then you push the play button, and then you construct the forecast that you want to do. And then we have a lot of other settings as well, but that we can take on another session. But otherwise, thank you very much for joining in today, and contact us if you want us to explain something more in details. So thank you for today. I will now end this webinar. So have a nice day and a nice week. Bye-bye.